So here, once we have high-level knowledge on what the client wants in product requirements, we know the timeline, the dependencies, we can create a high-level testing approach for the development cycle. For example, by looking at the timeline, we can establish testing types. So we can approximate when we will need to run regression tests or user acceptance tests. Then we have to consider how the testing process will be from sprint to sprint. For example, when the sprint starts, testers also start creating test cases, test scenarios, as this is the most time-consuming activity. And it's easier because when the ticket moves in test, they just run the tests and they already know what that ticket is about. They just had enough time to raise questions about requirements. They don't have to raise them for the first time when the ticket is in test. Another aspect of this is where and how we test. So usually there's a test environment where the dev branches are deployed, and that's where the feature testing is done. And another environment where the master branch is deployed. And the tester can smoke test the changes once the developer branch is merged to master. Also, we need to decide which test management tool we'd use. So in Code Factory, we usually use TestRail, as we can easily track test cases, test plans, test runs. Another important aspect is the compatibility. So we need to decide the browsers and their versions, or the operating systems where testing will be performed. This can come from the client strategic team, which researches the market in that specific country where the product will be released and comes up with the most used platforms. Now, when we speak about who's doing the testing, testing is done by both developers and testers on different layers, both manual and automated. So for component testing, we use unit tests, which are done by the developer. For integration testing, it's usually an effort done by both developer and automation tester. This is on the API level. Usually we use REST Assured and the programming language in which the application is written, like Scala or Java. We want this integration test to be run automatically at each build of our application, so we integrate it with Jenkins. This is to make sure we find as soon as possible any issues we may have with our code. Once we test each unit and different units integrated, we need to perform system testing. So this is done by testers, and it's usually manual, as it evaluates end-to-end system specifications. I just want to add that when I'm speaking about manual testing, it includes UI testing, API testing, database and logs check, not just UI testing. We do automate some major system flows, but these tests are considered smoke tests. We want that this smoke test to run at each new deployment, just to ensure that the most important functions work. The reason why we don't automate all system tests is because it's time consuming and not reliable, as many components are involved, and any change or downtime to any component can cause tests to fail. The last testing level, so we spoke about component unit testing, integration testing, smoke testing. Now the last test and system testing. The last testing level that will be done is UAT. Here we had different demands. Some customer wanted to be done by the same team that developed the application. Others prefer an external team. In either case, it's important to have good test scenarios and good documentation so that whoever picks up this task won't need extra training and will be able to complete in a short time. Depending on the timeline, the number of developers and level of testing coverage required we can determine the resources we need. So as an example, for a team of 8 developers, we start off with 2 manual testers and an automation tester. Well, of course, during the project, we can add more testers or developers if needed, as we can see better the team's velocity after a few sprints. When it comes to test analysis and design, this is also called test preparation. We perform all activities needed to be done in order to be able to execute the testing. So here is when the general testing objectives are transformed into test scenarios. As I said earlier, we usually start test preparation once a ticket is picked up by the developer. In this step, we just analyze what we will test by reviewing in more detail the requirements, noting down any questions that we may have for the product owner, for example. Let's say we have a requirement about creating a login button, but we don't have details about the location, the font, the color. So this is the kind of question that we would address to a product owner. Of course, there can be questions for the developer as well, like testing data, configuration changes, environment choice, and so on. When all these questions are answered, the testers define the testing plan and starts creating the test scenarios in the test management tool like TestRail in the grid format, like adding preconditions, making sure that we have a reusable format, using tags for test type, and so on. We also make sure that testers review each other's scenarios as a method to prevent using different formats or to help increasing the testing coverage, because usually the application knowledge can vary from tester to tester. In general, as a testing prep mindset, we always try to make the test scenarios as reusable as possible, so that when a change is done, we'd only have to change one test case, not all the related test cases. Let's move forward to the test execution. So now the code has passed, it went from development, it passed code review, and it's in test column. The tester can start creating the test run. This test run contains the feature testing scenarios, creating during test prep, and any already existing test cases that need to be tested to verify that the changes have no impact on already existing functionalities. Once a test run is created, then the tester runs the test step by step by comparing expected results with actual results. When the actual result is different from the expected result, then a defect will be documented and tracked in a software development tracking tool like Jira. That's what we usually use. When we create a defect, we add as much information as possible, such as database entries, logs, screenshots, so that the developer doesn't waste extra time investigating. The tester also adds the priority on the defect, so that the developer and the product owner can have an idea if there are major or minor issues and decide on the next steps. Handling on defects depends on the grid process. So we usually execute the whole test run and list all the defects before moving the ticket back in development for defect fixing. Once the developer fixes these defects, all feature tests will be rerun, even the initially passed ones, as any new change invalidates the first result. To determine if a story meets the expected quality, some metrics are agreed. So for example, what we do, we say that any story that needs to have at least 90% of the test results set to pass and no defects with priority 1 or 2 opened before QA can sign it off. So once we have the test execution results, we can assess it against these quality metrics, and we can evaluate the results, document them in a test report, and communicate the functionality, quality, and readiness to the stakeholders. All right, so in the end, I just want to add that each project is different and the testing approach differs from client to client, from project to project. When we establish how testing will be done, we always communicate with the client to suggest what we think is the best testing solution and to see what are their expectations regarding quality. Some projects need more focus on the user interface side, other on the backend side, and other on both. So we will have to adjust to this. This is all for me. I hope I provided you with enough information to give you an idea of how we are testing here at Code Factory. If anyone has any questions to raise, I'd be happy to answer.